Today we're going to start a new lesson in Chapter 11, Section 11.1 and 11.2, Area of Parallelograms and Triangles. But before we get into specifics of parallelograms and triangles, there are a few things we're going to talk about, or points to make. First, the area of a closed region is the number of square units of space within the boundary of the region. The area of a rectangle is base times height, as is basically the area of a square, which is a side square, which is the height versus the length, same as a rectangle. And that every closed region has an area. And finally, if two closed figures are congruent, then the areas are equal. And finally, if two closed regions intersect only along a common boundary, then the area of their union is equal to the sum of their individual areas. So let's say that we have a figure that looks like this, a triangle kind of stacked with a rectangle. What that means is that the area of the figure, since they're overlapping or intersect there, is equal to the sum of the triangle plus the rectangle. So I would calculate the area of the triangle, then the area of the rectangle. That will give me the area of the figure. Now let's talk about area of a parallelogram. A few things that we know about area of a parallelogram is the opposite sides will be congruent and opposite angles are congruent. If I draw a perpendicular line creating triangles, you'll notice that the two triangles are congruent. But more importantly, I can take this triangle right here and I can move it over here and it fits perfectly within that area. And what that does is now it's created this rectangle. So the area of a parallelogram can be calculated by base times height. The same as a rectangle. And finally, the area of a triangle. You'll probably remember from back in middle school, area of a triangle is half base times height. And the way that that formula kind of comes into play is similar to the parallelogram. Basically, if I extend two lines to make it perpendicular on both sides, and then make a line down the middle, you should hopefully notice that it creates two rectangles. And one over here as well. And you'll notice that this triangle in here is congruent to this triangle right here. So I can calculate the area of this rectangle, but I'll know that that triangle in there is half of that full length, as is the triangle on the right. This triangle is congruent to this triangle, so if I can calculate the area of the rectangle, know that this part will be half of it. So I calculate base times height, divide by 2, and that will give me the area of the triangle